look at is our quarterly based standards test. And they give us a question saying use the data in the table to find the closest estimate when x equals 60. So I think, okay, x is got to be 60. And 60 fits right in between 56 and 70. The distance from 56 to 60 is 4. The distance from 60 to 70 is 10. So I'm way closer to 56 than I am to 70. 4 units versus 10 units. So I know that the answer number has to be pretty close to whatever is underneath 56. And what we see is that it is 93 and 118. So we're pretty close to 93. Let's see how close. The difference between 93 and 118 is 25. And if I look through here, I can see these are about 25, 25, 25 apart here. So we look at what's our sample choices. We have 97, 101, and then a couple of these answers are just too high, like 106 and 108 are just too high. The choice is really between 97 and 101, and 97 is only 4 units away from 93. It has to be more than that. So 8 units away is much better estimate, closer to 25. So I treated this like an estimation question, and you could actually just compute the equation of the line if you wanted to, and then substitute in 60 for x, and that would give you a more exact answer. But I just wanted to use my powers of estimation here. Number 2, it gives us a graph, and we start with the origin. In our new absolute value vertex, we go over 2 units and up 1 unit. The slope of my line looks like it is going to be up 1 unit, over 1 unit, up 1 unit, over 1 unit. So this should be the absolute value of x here. Because I got shifted over 2 units this way, it's going to be x minus 2, because I went 2 units to the right. And then I got shifted up 1 unit to come to my new vertex. So I'm going to look for an answer that has absolute value x minus 2 plus 1. And that's going to be answer choice H. For number 3, we have to use a linear regression on our calculator. So first we go to lists and spreadsheets. When we get to lists and spreadsheets, we need to type in our coordinate points. Now, I wrote mine as a data table just so we could see like all of the numbers, how they're going to go into the calculator. So you're going to type in the calculator this exact list. As a matter of fact, you're even going to put x and y on the very top columns. After you do that, you can go to statistics, and then stat calculations, and then you're looking for option 3, which is linear regression. Set up your window. When you get all of your data to spit back out over in column C, all of your data will come out and it will say, you know, negative 1.8 is M, and C is 119.2 negative. Excuse me, positive. And so when you look at your answer, you're looking for the equation that has a slope of negative 1.8 and has a y-intercept of 119.2. And that's going to be answer A for number 3. All right. Let's look at an absolute value function. We've got an open dot here at -1 and an open dot here at 4, and our solution set is in between the two. So to be able to solve this out, the first one that they give us is 2x minus 3 in the absolute value symbol is less than 5. And we can solve this out a bunch of ways. We could just take a couple of test points here on the line and substitute in to our equation, see which one's true, which one's false. And I already did and went through that, and I thought that was a bit of a lengthy process. So what I want to do is actually try to solve this out by using algebra here. Okay, so here's what that would look like. We're ready to break our absolute value symbols, so we're going to have 2x minus 3 is less than 5, and 2x minus 3 is greater than negative 5. Less than. Excuse me. Okay, so we're going to add 3 to both sides, so 2x is less than 8. We're going to add 3 to both sides, so 2x is less than, greater than, sorry, I keep messing that up. It's greater than negative 2. We're going to divide by 2, and you get x is less than 4, and x is greater than negative 1. This is exactly what we see up here. X is less than 4, so here's 4, and it's less than, so we use an open circle. And x is greater than negative 1. So here's negative 1, and we use an open circle, and we shade all the numbers greater than negative 1. Okay, so that means that number 1, option 1, definitely works for us. Let's look at option 2. Option 2 says 6x minus 9 is less than 15 in the absolute value symbol. Like this. So this means when we're ready to break the absolute value symbol, we're going to have 6x minus 9 less than 15. 6x minus 9 is greater than negative 15. We're ready to add 9 to both sides. Alright, so we get 6x is less than 24. And 6x is greater than so then we can divide by 6. And we get x is less than 24 divided by 6 is 4. And then x is greater than negative 6 divided by 6 is negative 1. So here we get the exact same thing that we got last time in our other options, so 2 works for us as well. Now number 3, option 3 says the absolute value of 3 minus 2x is less than 5. 3 minus 2x is less than 5. So when we're ready to break the absolute value symbol, we're going to have 3 minus 2x is less than 5, and 3 minus 2x is greater than negative 5. We can subtract 3. We're going to get negative 2x less than 2, and negative 2x greater than negative 8. When we divide by a negative, we have to flip the direction of the inequality symbol. And since I have a negative 2 in my denominators here, that's going to happen here. We have x is greater than negative 1, and x is less than 4. X is less than 4, x is greater than negative 1. These are the exact same things that we got from the other 2 responses, so 3 works as well. Option 4 says the absolute value of 3x minus 2 is less than 5. So we're ready to break the absolute value symbols. We're going to say 3x minus 2 is less than 5, and 3x minus 2 is greater than negative 5. I can add 2 to both sides, and I come out with 3x is less than 5 and 2 is 7. And then over here, I get 3x is greater than negative 3. So I divide by my 3 here, and I get x is greater than negative 1. This is definitely true. Over here on this side, I divide by 3, and I get x is less than 7 over 3, which is not true. It's x is less than 4. So no good on this. Option 4 is definitely not the right answer, and this means that our final answer can be options 1, 2, and 3 only, and this will be letter G for your answer there. Alrighty, the very last one that they give us on this page is a rainstorm. It begins with a light rain. So here is T for time, and here is R for rainfall. And this is measured in millimeters per hour. They give us this equation here. It basically, they say it starts with a light rain. So light rain, it increases intensity, and then it decreases again. Now I knew to draw my graph this way for a couple of reasons. This negative sign out front tells me that I have to be pointing negative. I have to be pointing down with my graph. So it's not going to open up to the positive. It's going to open down to the negative down here. These are all negative numbers on the y-axis. I also have a t minus 5 in here. So minus 5, remember, flip the sign. Minus 5 becomes positive 5. And we're over here. 1, 2, 3, 4, 5. Here's positive 5. Done. And they also tell us that we went up 10 units. So we can come out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 10. And this is storms. Alright, so here's my graph for this. And they're just asking me, what is the maximum rainfall rate? So I look up here at my maximum. And my maximum happens at time, so 5 hours in. We are raining at a rate of 10 millimeters per hour. And that's the griddable that we put in here. We just say at 5 hours, the rate is 10 millimeters per hour. And this is a griddable question, so you would go over to your griddable and you would put in 10, and then you'd bubble in at the bottom. All right, that takes us through page 1 of our standards review. Stay tuned for the next lesson where we're going to go through the next couple of pages.